Welcome to Mrs. Neller's notes for her pre-calculus class. These are the notes for section 12.4, day 2, entitled Mathematics of Finance. And today we're going to talk more about the present value of an annuity and then installment buying. So when we start with the present value of an annuity, that's what you would get now in order to have a certain amount later. So let's just say that if you want to receive $10,000 5 years from now, would it be worth much less? Oh, it would be worth much less than if you got $10,000 right now. So in order to have that much more money later, you would have less money now, because that would assume that you would um, put it into an account and it would build interest, so you would make money over time into the future. Or it could be that if you borrow a certain amount now, you're actually paying back more later because it's building interest over time. Okay, so that's what we have to think about when we're dealing with present value versus that future ending value. Okay. So we kind of ask this question then, what smaller amount would you be willing to accept now instead of receiving the $10,000 in 5 years? So that's basically saying, okay, if you want that $10,000 in the future, what do you have to have right now to invest so that you can have the $10,000 in the future? What's that smaller money amount that it's equal to now? Okay. So the amount that we are looking for here is what we're going to call the discounted value or the present value. Okay, and it's discounted, not like you're getting a discount on it, not like it's 20% off. It's discounted because it's smaller. It's a smaller amount of money. Okay, so let's just say that our interest rate is 8% in this situation, and it's compounded quarterly, so that's 4 times a year. Okay, so then the interest per time period would be that 0.08 divided by 4, so that'd be 0.02. And then there are 20 time periods because it's 5 years from now and it's compounded quarterly. So 5 times 4 is 20. Okay. And then if we let the present value, PV, PV is going to denote the present value, then the formula for the compounded interest we have is going to be this. We're going to take that present value and we're going to multiply it by 1 plus our interest rate for n number of times, and that should equal the $10,000. So if we put in our 0.02 and then our 20, then we will be able to set it equal to the $10,000. But if we actually take this equation then, this 10,000 equals, and then this simplified set here, or step here on the right, if we actually take this and we solve it for PV, we end up getting a negative exponent. Okay, so if we actually resolve the equation, we would have to divide, and we would have this term in the denominator. So you could just divide by the 1 plus 0.02 to the 20th in the denominator, but that's the same as multiplying by a negative exponent in the numerator. So that's where that comes from. Okay? Either way, you get the same amount of money, but noticing that this exponent is negative, that's going to be key for our equation that we're going to be using in a moment. Okay? So in this situation, if I gave you $6,729.71, that would be the exact same amount of money that would get you $10,000 in the future for this situation where you're depositing 8% quarterly for 5 years. Okay? So it's like you can either have $10,000 in the future 5 years from now, or you can have this amount of money right now. Okay? So this is all leading up to the equation that we're going to be working with. Okay? And A sub P is going to be the present value that we'll have. We still have our interest rate. We have the N time periods. We still have our A sub F for the amount that's going to be paid in that lump sum, that future amount. Okay. And here again, we're dealing with a sum because we're taking all of these payments and we're adding them up over time. Okay. So that's why we're dealing with these types of equations in this chapter as well, because they're all sums. Okay. So here's our final equation then. They work through it a little bit more, but in this box right here, here's our final equation that we're going to be using. And again, this should be on your formula sheet. And we're still going to be dealing with R like we were before. That's the payment size. And then we have 1 minus 1 plus I, that's our interest rate. And then our N is the number of payments. Okay, so that's going to be negative now because we're trying to come back from the future. So they're giving us a future amount and then we're trying to work backwards to the present amount. So we're kind of going back in time. And then we're going to divide by I. Okay. So let's take a look at an example then that's going to use that. So here we have a person wins $10 million in the California lottery, and the amount is paid in yearly installments of $500,000 each for 20 years. What is the present value of his winnings, assuming that he can earn 10% interest compounded annually? Okay, so that means that at the end of those 20 years, he's going to have $10 million. But what is the current value of it right now? What is the starting value that he starts out with? Okay. So we have to go through and we have to identify all our important pieces of information here. So we need our R value. Okay, and that's going to be that installment of $500,000. Okay, and we're going to write it out as the actual numerical $500,000. Okay, 500,000. N, it's for 20 years, and we're going to make it negative because that's 20 years down the road, so we're kind of coming back in time to the present day. And then we've got our interest. Here it's assuming 10%, and it's compounded annually, so that 10% will make that a decimal, and then we'll divide it by 1 because it's divided annually one time, so that's really just 0.10. Okay? So then we're going to plug this information into our equation for A sub P. So that's going to be our present amount, the present value. Okay, and then R is kind of that installment amount, that rent that we were talking about in the previous section. Okay, and then here we're going to have our numerator is 1 minus 1 plus our interest to the negative 20 all over 0.10. So now it's just a calculator problem after you've substituted. So the hard part is really reading the problem, identifying the key pieces of information, knowing what equation to plug it into, knowing what situation you're dealing with. Okay. Here, whenever you see the phrase, phrase present value, that's a clue that you want to use this equation, obviously. Okay, so then as we simplify, we'll take the 1 plus 0.1, take that sum and raise it to the negative 20 power, and then take 1 minus whatever that value was, get an answer, divide by 0.1, and then multiply by the $500,000. So if you work through that, you should get 8.514 for that stuff that's in parentheses. And then when you multiply it by $500,000, you should get $4,256,781.86. So that's the present value of the money that he would have in the future. So in the future, after 20 years, he should have 10 million, but right now, that amount of money has a value of $4,256,781.86. So this is why when the lottery has an option of you can take a lump sum or you can take payments over a certain amount of time. Here, this would kind of be like the lump sum. Like, here's what it's worth right now. Boom, there's your money. Okay. All right, now the other concept we have to talk about then is installment buying. And this is a little more applicable, a little more real world. This is when you buy a house or a car, and the payments that you make are annuity, whose present value is the amount of the loan. Okay, so you go and you get a loan, and then you make installment payments on that loan. Okay, so for our example here, we're still going to be dealing with that A sub P, that present value equation. We're still going to be looking for our interest and the number and that rent or that R value. Okay, so here a student wishes to buy a car. She can afford to pay $200 per month. So that right there, that's that monthly amount that she's going to be able to afford and able to make as a payment. So that's our R value. That's the rent. Okay. Let's see, she can afford to pay $200 per month but has no money for a down payment. Okay, so we don't have to worry about subtracting anything off of there. If she can make these payments for 4 years, now that's key because that's going to affect our interest rate. And the interest rate is 12%. There we go. There's our interest rate. So 0.12, and we're going to divide it by 12. Okay, because it's going to be a yearly thing. Okay, so that interest rate is going to be over the whole year, and if she's doing monthly payments, then there's 12 months in a year. Okay. What purchase price can she afford? Now, the other thing we need is N, and let's see, it's monthly, and it's for 4 years, so we're going to take 12 times 4 and get 48 for our number of payments. So she's going to make a payment every month for 4 years. Okay. So we want to know what's that final amount that she will be able to take out as a loan if she's paying $200 per month at 12% interest for 4 years. Okay, so just in that situation. So A sub P is what we're going to be finding, and 200 is our R value. And then we'll have 1 minus the 1 plus 0.01 for our interest to the negative 48 all over 0.01. Okay, so again, plug that into your calculator, simplify it all down, take the 1 plus 0.01, raise that to the negative 48th power, subtract that from 1, and then divide by the 0.01, and you should get 37.974. And then when you multiply by the 200, you'll get the final amount, the $7,594.79. Okay, so that's the total amount she would pay in the future at the end of those 4 years. So that's how much she wants to take out now for her loan. Okay, as long as it's a fixed interest rate too. Okay, so again, the tricky part with these problems is just being able to read through them and pull out the important information, know what equation that you're supposed to be using. Okay. All right, one other equation that we have to work with here, it's basically the same equation that we've been working with, it's just resolved for R. So it's that A sub P formula for the present value, and it's just solved for R. Now you don't have to use this, but if you're trying to find that R value, that rent, that payment amount, it can be easier to do it in this form. The other way is to use the formula we were just using and then just divide at the end. Okay, so it's personal preference as to which one you want to use. All the information is the same. We still have a negative n there as well. We still have I. We have A sub P. Okay, so we're just going to go through this last example using that formula that's already solved for R, just so you can see how to use it, and then you can decide if you want to use that or if you want to use the original form and then just solve it for R. Okay, so here a couple is borrowing $100,000 at 9% interest. Okay, so right away, that's how much they're borrowing. That A sub P is going to be $100,000. That's the total amount. Okay. And 9% interest, that's our interest rate, so 0.09. Now we're going to have to divide it by something, so let's read on. They expect to make monthly payments, so I'm going to divide that by 12, and I'll get 0.0075. And they're going to do this for 30 years. Usually you get a 30-year mortgage. Okay, so we're going to do 30, and then we're going to multiply it by 12. So that's really going to be 360. And remember, our n value here will be negative, okay, since they're telling us the final value and we have to work backwards to figure out the current payments that we would have to make in order to end up paying that $100,000. So really we're dealing with a negative value here for negative 360. Okay. So what is the size of each payment? So that's that R value, okay? The rent, how much they're paying every single month. So we're going to start with our interest then, 0.0075, and then we'll multiply it by the A sub P, the amount that they're going to end up borrowing, but that's the total amount that they're borrowing and paying back in the future. Okay, so by the end of 30 years, that's how much they will have paid back. Okay. So then we have 1 minus 1 plus 0.0075 to the negative 360. That's where that comes in. Okay. So now it's a calculator problem. Okay, multiply out in your numerator, get that value, and then in the denominator, take the 1.0075 to the negative 360, and then subtract that from 1, and then you can divide your two amounts. And you should end up with $804.62. And that seems pretty reasonable for a monthly payment on a home mortgage. $800. It's probably a little high. You could argue, about where you're living and how big the house is and all that good stuff. Okay, but that answer should make sense. We don't want it to be more than $100,000. Okay, because that's the R value. That's every month. So if they pay this amount every month for 30 years, then they will have paid $100,000 back at the end. Okay? So this homework then is really just using equations that are very similar to the ones that we've been working with. We have our A sub F one that we worked with in the previous notes, and now we have the A sub P, and then we have the one where that A sub P equation is solved for R. Okay? So again, it's more just reading these problems. There's not many of them, making sure that you know how to pull out the important information and substitute it into the equation correctly and work through the equation so you get the correct answer. Okay. Check your answers in the back of the book. Solutions are on the class website, but if you have questions, come on in and see me before school.